Wonderful evening, my dear students. I'm back. So in this video, we are going to discuss about our subtopic, which is a continuation of our previous video of basic mathematics. I hope all of you guys have watched that video because based on that is our vectors chapter. So before we go into this video, let's subscribe to our channel first. And if you like my explanation, hit the like button and share to your friends if you want to help them. Unless you're, a bit eager to get marks and don't want to share it. Hmm? Okay, leave about that. So basically, let's start the lesson. Let's say continue the lesson. So this vectors is a big lesson, and we'll divide it into two. Okay, let's get started. I'll share my screen. I'll just zoom in up here. Yep. Now, chapter vectors is a lesson which you won't understand even if you read it twice or thrice. That's what, if once a teacher or anyone explains to you, it's better to listen so that you'll understand. Now, vectors are nothing but physical quantities which are used to measure. Okay. Now, in physical quantities, these quantities are divided into scalars and vectors, okay, based on the characteristics. Okay, so based on the characteristics, our scalars are basically quantities which have a measurement like a magnitude or length, but they don't have any direction, a specified direction. Example, let's say time, speed, distance. All of these, if you take examples for these, can you say that it shows a particular, what do you say? Direction? No, right? Let's say mass. Mass just gives you the weight. It gives a measure, but it does not give you a proper direction, like which direction the mass is acting on and all, right? So, again, one more displacement, distance between 1 point to 2 points. There might be some x value, some x units displacement, but will it show which direction is there? No, whereas vectors are opposite of scalars, not completely, but vectors are physical quantities which have a proper measure as well as shows the proper direction. It is more clearly used. So we have many vast examples for vectors as well as displacement, velocity, force, acceleration, torque, momentum, all of these. For if I give you examples of vectors, can we say this displacement like an object moved, let's say this is an object moved from its initial point to from its initial point let's say 3 kilometers towards east. It moved 3 kilometers towards east. Okay, if you mention specifically like that, can the person who doesn't know can know which direction it went and how much kilometer it went, right? Now, the same displacement or okay, that's one example, tiny example. Just wanted clarity, to give clarity. Now, okay. Now the same displacement, if you keep it in the XY plane, coordinate system plane, I hope everyone knows that. So in the coordinate system plane, from its origin O, it moves 5 units towards east. 5 units, this is x, right? This is minus x, y, and minus y. I hope you everyone know. And coming to vectors, we have directions also. That I guess everyone know again. East, west, north, south. So when a person says the particle moved, once again, when a person says a particle moved 5 units towards east, 5 units towards east, and 7 units towards north, means they're telling that it went 5 units x 1, 2, 3, 4, 5. Like 5x. You write it as 5x. So here there's an actually, I'll tell you, 5x. And then towards north means 6 units, 7, right? I told 7. 3, 4, 5, 6, 7. 7 units towards north means 7y. Clear? Now there's a representation as we can't take 5x and 7y because they are variables. I mean variables in the sense they'll have other meanings too. So we have representations for unit vectors. Okay, before this, unit vectors are nothing but vectors which show the direction of a vector. Now, and whose magnitude is equal to 1, or it's just 1 unit. Now, here this one and this one is a unit vector. So the components of x-axis will be represented by an I cap. I cap, a unit vector is represented by an I cap. And in y we have j cap. And then z axis, I guess we all know z axis, the 3D model z axis, which is just coming front like this. Z axis. I mean, it points outside, which I can't show on this 2D board. Okay. So z axis, and z axis we have k cap. So cap is used to resemble, it is a unit vector. So if you have 5 units towards your north or 5 units in your x-axis, it is represented as 5i cap. Clear? And then 7 units towards your north or 7 units in the xy plane towards y, it is represented as plus 7j cap. And if they give you like 2 units towards your z-axis, then you write it as plus 2k cap. Clear? This is also known as vector form. Clear? This is known as vector form. Now, before we rush into other stuff, this is the basic thing which you have to know. And I guess I've already told you what is a unit vector, but let's revise the types of vectors quickly. Now, types of vectors is nothing, complex. We just have parallel vectors. Parallel vectors are vectors going in the same direction, but having different magnitudes. Okay. And anti-parallel vectors are vectors which act in opposite direction with different magnitude, right? Then equal vectors are vectors which act in same direction and have same magnitude. Then unit vectors, very important one, with the main thing few sums are based on is a unit vector. I'll write it here. A unit vector is a vector, as I told now only, is a vector used to represent the direction of any vector in a specified path. That's what an I specifically show that it's an x-axis, j on y and k on z-axis. Clear? Now, whose magnitude is equal to 1 and its magnitude is also equal to 1. Clear? Magnitude is nothing but the length. Okay? There's a formula to calculate that, which we will see. Now, the unit vector formula is the vector form, which is nothing but a vector A. And I guess this is basics, which we know that vectors represented is like this by magnitude of that particular vector. Now, I'll tell you how do we calculate a magnitude, which is very simple and easy. Now, yes. Okay, let's go to the next slide. Now, if you say in an XY coordinate plane, there's a vector, okay, there's a vector here, let's name it as R bar, R vector. So this, if this line related is known as Rx because it's on Rx. And if you draw an imaginary line, this is Ry, am I right? Now there's a theta formed between them. So it formed a triangle and we use trigonometry here. Okay, that's different. But for now, as we know this Pythagoras theorem, by this Pythagoras theorem, can you say that R square is equals to R square is equals to Rx whole square or rx square plus ry square. Can we say that? Yes, we can. But if you want to find the particular magnitude or length of the r, then the square goes the other side and will become root, right? So the formula of magnitude is rx square plus ry square. Clear? Now, if you have a 3D dimensional again, if it's we have an rz also, then you have plus rz square. Once again, plus rz square. Clear? So the main thing will solve few problems based on this also. The formula. The formula. Remember the slide. This slide is very important. Okay. Now, I hope we are clear with how did you get this. We'll solve few problems based on this. But there's also one more thing point which I wanted to tell. When they give you a triangle like this, a triangle is nothing but a vector. Let's say a vector here. A vector is here. They are asking you to calculate it with the r and rx, the angle between r and rx. To find the angle between r and rx, which is nothing but theta minus, this is theta. If it is here, the vector, we say this as theta. If it goes this side, we can say it as 180 minus theta. Now 180 minus theta is nothing but when it's like this. So the angle here, this part I drew it here. Okay, this is r, this is rx. Now, when it's like this, if you want to calculate the angle, we don't calculate it here. What do we do? I'll change the color. What do we do is basically, we basically transpose the same vector this side. And then we'll calculate this theta. Understood? Clear? That's another point. So, I hope we are clear with the magnitude and this way. Now, I think it's good if we solve, at least one problem, an example related to magnitude. Example, let's give 4i cap plus 3j cap. Now, I told you what are I cap and j cap means 4 units towards your east and 3 units towards your north in x-axis and y-axis plane. So to find the magnitude by using the formula, what do you do is r or magnitude is equal to magnitude. If we have this vector as r, this vector r measure, okay? Then we can tell at 4 square plus 3 square, which is nothing but root over 25, right? 16 plus 9. Root over 25 is what? 5. So can we say that the magnitude of our r bar is 5, right? Like this. This is the simple way we can calculate. Okay. Now we will see how to find the angle between the our this vector and x-axis. Okay. Wait, I'll create this. Yes. Now it's not something complex. 1 second. I'll just draw this a bit small. Okay. So this is your xy plane. X, y. Clear? Now this is the vector. Let's say r. And let's draw an imaginary line, ry and rx here. Let's name this triangle as OPQ. And now this is theta. So today this is if r bar or r vector makes an angle with x-axis, theta. We'll find how. So sine theta. First let's use sine theta. But okay, to find the angle we have another formula which is tan theta. We use tan theta, which is nothing but ry by rx. But before that, you have to know the values of rx and ry. That's what we will see this. If you use sine theta is equal to pq by oq. Sorry, pq by po. Right? pq by oq. Sorry, just a mistake. It's a pq, this pq ry by opposite by hypotenuse, ry by r. Now, can we say that ry is nothing but sine theta into r is ry? Same as that cos theta. This is not 30, sorry. This is theta. This is theta. They will mention you sometime the vector angle if they ask you to find the ry and rx components. So cos theta is equals to, I'm sorry. Yes, just a second. Yeah, cos theta is equal cos theta into r is equals to rx. So we'll get how we will find the r and rx and ry components, right? So based on these components, we'll again get the vector form, which is r bar is equals to rx I cap plus rj cap or ry j cap. Okay, just a second. Yes, ry j cap. Now let's go to another screen. Now let's try a few problems. Let's try a few problems by seeing. I'll give one example problem for today. Uh, let's go with the notes. Just trying something fun. Okay. Now let's say this is in your xy plane. Sorry for the slanting lines. And this, the measure of our vector is 15 and the angle is 37 degrees. Now, and then we draw an imaginary line and name this as ry and rx. So they're telling us to write the vector form of this. Now, previously we have remembered this is our vector form. So we are going to solve the components, solve this into components basically, and write it into vector forms. Clear? Now, ry, one second, yeah, ry is equals to sine theta into r. We have discussed before. Sine 37 degrees. Sine 37 degrees into r, which is 15 here, right? 15. So sine 37 is 3 by 5. So 3 by 5 into 15 is equals to 5 ones and 5 threes, 9, right? What you get is 9. Yeah. So then Rx is equals to cos 37 into 15. Cos 37 here is 4 children. Sorry, 4 by 5. 4 by 5 into 15, then 5 ones and 5 threes. So 5 threes are, sorry, 4 threes are 12. So we got 15, I mean Rx and Ry. So can we write the vector form? The color didn't change. Just a second. Yeah. Can we write the vector form as 12 cap plus 9j cap? Clear? This is how you do, you write. Understood? Now I hope you are clear with the formula. And then we are gonna see how to find angles here. So there is a point here which you have to note down. I've told you here only that tan theta formula is to find the direction of the vector r in 2D figure. So the angle made by r with x-axis is tan theta, which is ry by rx. Now, if the value of ry by rx is a negative, then we can say that this vector is traveling in clockwise direction. If it's positive, it is traveling in anti-clockwise direction. Clear? Now, then we will see direction cosines right now. I'll add another slide. Yes, now coming to directional cosines, a very important lesson. Directional cosines. So directional cosines is nothing but we are trying to find the theta of the vector between x-axis, y-axis, and z-axis also. Clear? Now, I'll draw a diagram. This is the vector. This vector makes alpha with x-axis, beta with y-axis, and gamma with z-axis. Alpha, beta, gamma are just what is this? Representations for now. Okay. Now, can we say from let's take both these triangles like this. This is B, A, and O. From triangle OAB, we can say that cos alpha is equals to Rx by R. This is Rx, remember, Rx by R. Cos is adjacent by hypotenuse, right? And cos beta from triangle OAC, can we say that it is Ry by R? And from cos gamma, if you check it, I mean, we don't have that. I mean, we can't show it. So based on these two perspectives, we can say that cos gamma is equal to, 1 second, cos gamma is equal to Rz by R. Clear? Now, what we will do is we will try to do the magnitude of these. Okay? So there's a point to be noted down that the magnitude R is equals to root over, let's take the variables x square plus y square plus z square. Let's take it like this, z square. Then if you square on both sides, this will become R square. We can say that R square is equals to square and this gets cancelled. So x square plus y square plus z square. Clear? This is a point to be noted down. Now, yes. Now what will you do is the same. So after you get this value, you'll square, I mean, we squared here. After squaring, we'll add all the three values of cos. Okay? We'll square these values, which is nothing but cos square alpha plus cos square beta plus cos square gamma. Okay? Square, there's no space here, cos square gamma is equal to nothing but rx square plus ry square plus rz square, but you'll have r square here, so I'm taking it like this fully. Okay, rz square, not rz, r square. Now from this we have seen that r square, this is nothing but r square, so r square by r square means 1 gets cancelled and you'll get the value 1. So there is the law for today. Law for today is, just a second, yes, yeah, now the law for today is cos square alpha plus cos square beta plus cos square gamma is equal to 1. Okay, this is very important. This is the whole thing is called as directional cosines. So with this, we'll be done with the concept, like basic concept. Now in this video, the last part of this video is about addition and subtraction of vectors. Okay, let's see that. In addition and subtraction of vectors also, you have many different methods like parallelogram law, we have triangle law, law, or we have a pentagon law. We'll all discuss about all of these in our next part. So for now, I'll just give you the basic vector addition. Okay. Let's see this, or let's go with black. Let's try black. Okay. The problem with black is I can't see, right? Vector addition and subtraction. Okay. Okay. Now there's a formula. Let's say that A bar is equals to AXI cap plus AYJ cap plus AZK cap, and B bar is equals to same like this, BXI cap plus, just a second, yeah, BYJ cap plus BZK cap. If you have it like this, now if you want to add A bar plus B bar, the formula is simple. It is nothing but you'll add the terms, which is AX plus BX, AX plus BX whole I cap. It's better if I change the color, students. I can't see. Fine. I cap. I'll just write this again. This part. The rest I hope you can understand. Okay. Now A bar plus B bar is equals to, we'll just add the terms. So I'll write like this. AX plus BX whole power I cap, whole, not power, but whole I cap, plus AY by AY plus BY whole J cap, and plus AZ plus BZ whole K cap, right? Now then A bar minus B bar is also same. We'll just subtract here. AX minus BX plus wait, I cap plus AY minus BY J cap. We'll just subtract the values, but the rest are same. AZ minus BZ K cap. Clear? So this is the basic thing which we have to know. And with this, we are done with part 1 for our vectors. So I'll stop the video right now. If you like my explanation, please subscribe to my channel. Bye, guys.